Another nice alternative to run Elmer on your computer is to use containers. In particular, I'm talking here of Docker. If you don't know what Docker is, you can look it up on the internet. If you go to docker.com, you get a lot of information and also, of course, the possibility to download. In short, a container is a encapsulated environment inside your operating system, providing all the necessary means of running certain software. So you can tailor it, yet it is strongly entangled with your operating system. The basis for Docker are so-called Docker files, and CSC provides you with a whole suite of those files. They are mainly for DevOps, so for development, but we recently included also a runtime or a run environment for the latest Ubuntu there. So if you want to check that out, go to github.com, Elmer CSC, and then check out Elmer FEM Docker. Somewhat slow internet today. Here we go. Well, read the README. De facto, the latest edition of this environment is not here. This will be updated. But to get the code, you can get this address here, and then going to your disk, you do a git clone with that address, and this will then provide you with a Elmer FEM Docker subdirectory. And let's have a look. The Docker file we are talking about here is Docker file runenv Ubuntu Focal. So let's have a look what's in there. I'm using Emacs. It's a normal text file. It's kind of a recipe to build up your container. So it starts with an existing container, in this case Ubuntu Focal, which is the latest LTS, and then adds certain packages one needs to compile Elmer therein. So basically what you do is you have an encapsulated environment where you run Ubuntu, this flavor Focal, and then basically tailor your environment such that you can first install the necessary libraries and then install and compile Elmer on top of it. The catch here is that graphical user interface at least is difficult to use, so it's just plain text communication with this container. So all you basically want to do is install the Elmer binaries and not the Elmer GUI here. So this is kind of a cook recipe, and now you have the possibility to directly take this one and create yourself a Docker image first and then run it in a container. But even more so, for your convenience, we added a makefile here. Most of it is for development stuff to test Elmer on new platforms. But what you are interested in is this runenv environment or runenv make command. And I will demonstrate how this works. So naturally, first of all, you have to have installed Docker in your system, and then using the make file. So we have to go one level higher. Here's the make file. We say make, and checking out here, run env dash Ubuntu Focal. Be aware that Ubuntu Focal is the only one that at the moment has this defined. The advantage here, it's a really closed container, so you don't need any stuff from outside. You punch that in, and then the system or Docker starts to first get the base image from Ubuntu Focal, then does all the updates therein, will download the source code of Elmer inside the container, will configure it and compile it and install it. Naturally, this takes quite some time because it's basically the whole process of building up a operating system with the necessary libraries, and then downloading source code and compiling it. So depending on your machine, this will take some time. The good thing is it's automatically done such that in processes that enable it inside the container while building it up, the available maximum amount of cores which is inquired by the makefile, or actually inside the Docker system, will be used. So like in my case, I have a 6-core CPU. It will use all the 6 cores for configuring and particular compiling Elmer. But I paused that, and let's pick it up once the Docker image is ready to be used. Just to show you that the system uses all cores while compiling Elmer inside the container. And you also see that basically everything is run inside the operating system through the container. While it's still compiling, let me point out that Docker is available on basically every major operating system, such as of course Linux, but also Windows and Mac. So it gives you the possibility to really be very flexible here, similar like a virtual machine, but way more lightweight. Okay, it's done. Ignore that error down here. We would have had to create a subdirectory called stamps, but it doesn't really matter. I will show you in a second. What is shown here, that if you want to interactively run now something with Elmer Solver, which I will demo, is then you can use this Docker command. Also, you can use Docker image ls for listing to show the current existing Docker images, which I have quite a lot of, but the latest one that has been finished about a minute ago, as it says here, is exactly Elmer run and Ubuntu Focal. Okay, so next step then is to demonstrate how to run a certain case with that just built Docker image. Right, so for that purpose I changed into a subdirectory which contains a whole Elmer case. Let me shortly show you what the whole thing is about. So we have a box which contains the letters of Elmer, and we will just compute the flow of a highly viscous oil through this box, and compute a heat transfer from these heated letters to the surrounding fluid. It has quite, for a PC at least, large number of cells with more than 2 millions and about a little bit less than 400,000 nodes, so it is far from being a small problem. So to first test whether the latest Docker image actually works, we make a short test run. We say Docker run in order to get the test. We add the option -IT for interactive and getting a terminal allocated there, and we can include the current work directory with -v, and in order to get the directory we simply give the pwd command with the option -lp and we will mount it to the home directory, which is the working directory inside the container. So this basically takes your local directory, the one where this example resides in, and will mount it on the home directory inside your container. Then next thing is to declare what container we want to use, and it's this one we just created, naturally with a space in between. And then we want to also tell it what to do. So you could just say execute bash, then you would get the terminal, or we can just execute a list in order to verify that actually in the home directory inside the container we really have the corresponding set of files that is on our host system in this very directory. So let's do that. And indeed, so doing the listing via the Docker and the listing via here gives us the same list of files. That's very reassuring, and de facto running Elmer then is a very similar thing. So we bring back the previous command and instead tell it to use user local Elmer bin Elmer solver, which is the path to the Elmer solver executable. I hope I didn't make a typo here, we will see in a second. And then as an argument we give flow sif. So this would launch a serial run of this quite large problem inside the container. So let's punch enter, and indeed it seems to work. Let's verify that with our top command, and indeed you see user local Elmer bin running inside the container at the moment here. This is not very satisfying because it's a serial run now, and it's very slow because it's a huge system. So the problem then, you can't use Ctrl+C to kill it. Let's try. No, it doesn't work because it runs in the container and you don't have any access to this container from here. So what you have to do is then to do what we already did before, Docker, but now a container instead of image list, and you see the current container running since 2 minutes, and then you have to do a Docker container kill, and then use this identifier here in order to kill it, and the whole thing will stop. and let's see if this container still lives. No. You can see terminated containers with ls-a, and you will see all the containers basically that we have been using. Let me point out that these can take up quite a large amount of disk space. So what you want to do from time to time is do a docker container prune to get rid of all these unused containers. It for security will ask you whether you want to do it, and then it does it. Here it was not so dramatic, so 16 or about 17 megabytes, but if you accumulate a lot of those containers, this can make up quite a lot of disk space, and you want to clean things up from time to time. Right, so next step then is to go for parallel run, and not a lot of things have to be changed here. What you have to add here is MPI run minus NP, and then naturally the maximum number of your available cores. In my case, I have a PC with 6 cores, and then it's also, but okay, let's punch that and see what happens, because there will be an error message most likely. So let's do that. Yes. So this comes from your MPI inside the Docker. Docker has the feature, let's call it a feature, that everything is run in root. That can be a security problem, so usually it is not. So when you run that, don't worry, but you should be aware of that. And as the text suggests, it is not recommended to run MPI as root, but inside the container you can do it, and you have to add that as an argument to your MPI call. So what we will do is now recall the previous command, and after MPI insert the allow as root option, and once I punch enter, we see that if I scroll up, that we are running in parallel on 6 cores, and this can be also verified by the top command. Yes, so we'll see that all 6 cores are now engaged computing our flow problem, which should accelerate now in speed. De facto it does, so it's quite advanced already. You see the time levels go much faster than before. Again, if you would like to interrupt that run before it's ended, you have to again check out the current running Docker container and kill that container. So to show you once again, it's a Docker container ls, and here you would get the identifier in order to kill it. De facto, there is another way actually to interact with this container. You can check out the container number again. So let's do a Docker container ls, okay, and then you can give docker exec minus it. Again, you remember this was the interactive interaction with the container, and then you copy that ID and say bash. You just want to execute a shell, and this actually gives you access in type of a shell to the container that puts its output here. And for instance, you can do a ps minus EAF and then just grep for Elmer solver, and you will see the processes running inside the container that at the moment solve your problem, which also means that you can do a pkill might be the better command. So let's try if this works. Yes. So we now killed all the processes, and at the same time this computation also of course stopped. And let's check Docker container ls reports then this container no longer to exist. If we give -a, you will see that both our previously failed MPI run container and the one that worked are still around. So what you want to do is, if you want to clean up, say again Docker container prune, and you clear the used space by those two guys. So this was a short introduction on how to utilize the by the Elmer provided Docker machinery to build your own Docker image and to run it, in this case here, on a Linux machine, but there are also interfaces for running stuff on Windows machines, or actually on Mac. It works pretty similar like here, because you can do it from the command line.